Hi folks, let's take a look at this first example here. So what we're interested in graphing is the function 1 over x minus 2, but I want to graph that by relating it to the polynomial in the denominator. Okay, so I want to think of this as the reciprocal of the function x minus 2. Okay, so the first thing I'm going to do is graph this function. Okay, so let's get some axes here. Okay. So since I know I'm going to be taking the function x and bringing it down, maybe what I'll do is I'll put my axis a little higher. Okay, so let's see here. So let's make this 1, 2, and 1, 2, nice and easy. Okay, so I know that if this is my function x, I'm just going to be bringing it down by 2 units. So let's try to get a decent graph here. So this is what the function x equals 2 looks like. All right. So this is usually the process that I would go to, is I would first start by identifying the x-intercept or x-intercepts in some of the other questions of my original function, because I know that's where the new function is not going to be defined. Okay. So we should already know what 1 over x minus 2 looks like. So I know there's going to be asymptote there. But the next step is to look at the behavior of x minus 2 near the 0. Okay? So as x gets closer to 2 from the right, we see that the y values are getting closer and closer to 0. Okay? So if I take the reciprocal of very small numbers, so here the y values of 1/2, 1 over 10, let's go again, 1 over a million, 1 over a billion. When I take the reciprocals, what am I going to get? Very large numbers. So I know that I'm going to have an asymptote there. And if I look at the behavior from the left, what happens to these y values? They're getting very close to 0, but on the negative side. So I'm taking the reciprocal of, negative 1/2, negative 1 over 10, negative 1 over a million. When I take those reciprocals, I get numbers that are getting smaller and smaller and smaller, going to negative infinity. So it looks as though we're going to have a vertical asymptote at that point there. So no value at 2, which we expect, but what we have is the behavior near 2. Okay, let's go to end behavior. Okay, this is very similar to the other one we saw. As the x values get large, the y values also get large. But what happens when I take these y values and take their reciprocals? These very large numbers, when I take the reciprocals, are going to become very small. They're going to get closer to 0 without ever approaching 0. And similarly, what's happening as x goes to negative infinity, the numbers are getting very, very small. They're getting more and more negative. And what happens when I take the reciprocal of negative 1 billion, I get negative 1 over a billion, so something very close to 0, but still negative. Okay? And the last thing I'm going to use here is I'm going to say, well, when are these two values going to be the same? Well, they're going to be the same when my y value for f is equal to 1. So where is this line equal to 1? There we go, right here. When I take the reciprocal of 1, I still get 1. And so now we have enough information to connect this and create one branch of this function. And they're also going to be equal when the y value here is going to be equal to negative 1, which only occurs at that point. And so now we have enough information to draw our graph. And this is exactly the graph you would have expected, I think, which is just 1 over x moved over to the right by 2 units. Okay, which will affect the vertical asymptote. So now the next 3 questions are a little more interesting, because these are functions that you don't know yet what they should look like. But we're going to follow the exact same pattern. So I want you to try B, and we'll come back together soon.